Good morning, everybody. We're going to start today a new lesson. We're going to talk about the similarities. We need to differentiate between two things. When we can say we have two triangles and they are congruent, and we have two triangles and they are similar. In the first case, we have the same triangle with the same size, same measure of angles, and same length. See, it's exactly the same. It's copied the same exactly. So in this case, we're going to say that they are congruent. Exactly the same measure of angles and same length of sides. But in the second case, we have the same shape, but we don't have the same length of sides. All the angles, opposite angles, are congruent, but we don't have the same length of sides. In this case, the sides, they are in proportion. So if this side is 2 and this side is 4, this side is a 3, the fourth side should be multiplied by 2, it will become 6. So they are in a proportion. This means this side over this side, if it will give me 1/2, so this side over this side will give me also 1/2. It's the same scale factor. Okay, so in this case, congruent. And now we're going to start this question. The two shapes are similar, not congruent, similar. We need to find the length of x. We need to know that if we have two similar shapes, that the sides, they are in a proportion. So this side over this side, which is 8 over 12, it's equal to 5 over x. They will give me the same scale factor. And using the cross multiplication, 5 multiplied by 12, it's equal to 8 multiplied by x. In this case, 5 multiplied by 12, we're going to get it equal to 60. It's equal to 8x. And if I'll divide each side by 8, I'm going to get x equal to 7.5. So I can know now that x equal to 7.5. Okay. First of all, we need to know what's the scale factor of this figure. The scale factor in this case, it will be the 8 over 12. And if it's in its simplest form, I'll divide it by 4. It will become 2 over 3. So in this case, the scale factor will be 2 over 3. So every time, if I want to get any new thing, I need to use the cross multiplication to get the missing part. We can see here that the scale factor is 2 over 3. And in this case, it's the same thing, 7.5. Some students, they will say, okay, we can divide 12 by 8 to get the scale factor. It's exactly the same thing. So if you will say 12 over 8, it's equal to x over 5. And also using the cross multiplication, I'm going to get 60 equal to 8 over 8x, and we will divide to get the same answer. Okay, going for the next question now. Try using the scale factor to find the unknown variable. I want to leave this question for you, and another question also for you. Okay, going for the next part. We need to know first of all that we have similar shape. I need to compare triangle with triangle, rectangle with rectangle to say that they are similar. In this case, we cannot compare triangle with a trapezoid or trapezium. We cannot compare them. I can say CD over DE because DE, it's a side in the trapezoid, and CD, it's a side in a triangle. So if they are similar, I need to check which two shapes they are similar here. So I need to compare a triangle with another triangle, but searching for this triangle, it will be the big one, see? Or, in the diagram, it's given for me that BCD, this small triangle, is similar to the triangle ECA. Okay, so the big one, it's similar to the small one. So it's easy for you to draw it down like this. I'm going to say this triangle CDB, and I'm going to name this side 4 centimeters, and this is parallel to the other big triangle, while the big triangle name is CEA, and I'm going to say it's parallel to EA parallel to DB, and the whole side CE, it's 10 centimeters because it's given in the question, it's equal to 4 and 6. And the downside, it's 7.5. It's given in the question. They are asking me to find BD. As what we did before, we can direct say on the question that this side CD over CE, it's equal to BD over AE. See, I got one side in the small triangle with one side in the big triangle. I can get the scale factor of that one, which is 4 over 10. Then I'll compare it with BD over AE. This missed side over 7.5. Okay. You can do it direct on the question, or you can separate the two triangles. If you will separate the two triangles, you're going to get the same thing exactly. You're going to say 4 over 10, one side from the small triangle over the big side in the big triangle. It's equal to the unknown variable, what I need to find, over the other side, which is 7.5. And again, using the cross multiplication, I'm going to get 4 multiplied by 7.5 divided by 10, the answer equal to 3. So in this case, the missed side equal to 3 centimeters. This is another question. I'm going to keep it for you. We have here quadrilaterals. We have the side equal to 6 centimeters and this is 10 centimeters. If you can see, we see here, we have this is 110, 110, 80 and 80, and they give me that the two shapes are similar. They want you find PQ this side and AD this side. So I'm going to keep this question for you to do. I'm going to start the new question, which is this one. The diagram shows a square inside a triangle. DEF is a straight line. What is the length of EF? To start, we need to prove that we have two shapes and the two shapes are similar. Because they give me here that this is a square, so I can say that this side is parallel to this side. We know that the opposite sides in the square should be parallel every time. And the measure of the angle should be 90 degrees in the square. So if I'll draw this shape, I'm going to get it in another way, like this. We're going to get small triangle and we're going to get the big triangle. What they give me? They give me that this side parallel to this side because I'm dealing with sides of square. If I'll connect this one with this one, I'm going to get that this side is equal to 12. All the sides are the same in the square. So also this side is equal to 12 centimeters. They give me that this side is equal to 15 centimeters still here. Okay. Now what I want to find this missing part. They ask me to find this. I'm going to find this missing part. You know why? Because I need to compare here the small triangle with the big triangle. So in the big triangle, if you can see, I can find this. I can find, in this case, this missing part, which is why using the Pythagoras theorem. You know, in the Pythagoras theorem, we have 15, 90 degrees, and this 12. So I can find the missing side, saying 15 squared, it's equal to y squared plus 12 squared. So in this case, if I'll say 15 squared minus the 12 squared, I'm going to get the y squared. So I'm going to say now 15 squared minus 12 squared, I'm going to get 81 equal to y squared. Taking the square root of each side, I'm going to get y equal to 9. So in this case, this part equal to 9 centimeter. So this one will be 9 centimeter. So according to this, the whole side in this triangle, if you can see, this is what I'm going to use now for my new graph. In the big triangle, we have this side equal to 9 plus 12, which is equal to 21. And this side equal to 15 centimeters. This is what I need to find now. This side is given in the question, it's equal to 12 centimeters. I can now use the scale factor, which is 12 over 21 to find the missing part x. So I'm going to say in the small triangle, this side x over the big side, which is x plus 15, it's equal to this side in the small triangle, 12, over the big side, which is 21. And as what we did before, we can use expanding the 12 inside the brackets. I'm going to get 12x plus 180 equal to 21x. Then I'll subtract 12x from each side. I'm going to get 180 equal to 9x.
by dividing each side by 9, I'm gonna get x equal to 20, and that's it. Thank you.